As Nikilia mentioned, my name is Laurenzo and I'm based in Suriname. It's a pleasure for me to share ICA's work that is being conducted in relation to climate smart technology. And for this presentation, today layout will be on a project that we have implemented recently. We will have the project summary, objective, and the specific objectives. The deliverables under the project and achievements, the summary farmers experience, and the positive agroecological practices and benefits. In the picture, you see there on the right side, the beneficiary, the group that we work with under this project. The group name is Duurzame Ontwikkeling naar Zee. It is a group that is on the coast of Suriname, and it is one of the main vegetable producing community, farmers community of Suriname. As mentioned, I'll talk a little bit about the project summary. The project title was Farmers' Vulnerability to Climate Change Impacts through the Promotion of Climate Smart Agriculture Technology in Suriname. It had a budget amount of approximately 266,000 with an implementation duration of 18 months. It was an initiative on the GCCA Plus Suriname Adaptation Project and funded by the European Union in collaboration with UNDP Suriname. The overall objective of this project was to strengthen the resilience of the agriculture sector to the negative impacts of climate change through the promotion and use of climate smart agriculture technologies. For the specific objective was to reduce farmer vulnerability to climate change impacts through the building of knowledge and skills in the use of management of protected agriculture structures, micro-irrigation, rainwater harvesting system for sustainable commercial vegetable production. On our main activity, we use a framework called TDI, where we train farmers, demonstrate and implement. As mentioned, the area we work in was Wehnasi. That literally means the road to the sea. In our case, it was the Atlantic Ocean. And this area is located on the northwest of the capital, Paramaribo. As mentioned before, it's one of the main vegetable producing areas of Suriname, with a population of approximately 16,000, according to a census held in 2012. The pictures shows us the demonstration units installed. We had the protected agriculture structures, the micro-irrigation system, water reservoir lined with HDPE pond liner to protect contamination of saltwater intrusions. And on the three other pictures, as mentioned, we have trainings for farmers, conducted trainings for farmers, in-house training, as well as practical field trainings, where you see our very own Dr. Jenny guiding the farmers in the field. In regards to the design that we have established, we did two double ridge protected agriculture structure with a dimension of 45 meters by 9 by 7.5 meters. Compared to the design that we have in Suriname, it is a very tall protected agriculture structure based to exactly increase the air circulation within the protected agriculture structure. We know that Suriname has a high humidity factor and high temperature, hence the design that we have chosen for this region. The other components within the protected agriculture structure is the covering of the total covering of the sidewalls with anti-insect netting to keep out pests and diseases, and to improve or to better manage the humidity factors, temperature factors. We also had a misting systems completed together with 2 circulating fan and 4 suction fan to help the management of temperature and humidity within the protected agriculture structure. for a well development of the plants, we have used hydroponic production system, soilless culture. With I want to highlight this, that we use a local base mixed substrate mixture of river sand and rice chaff in a ratio of 20% river sand and 80% river sand. This because it is widely locally available, it is being discarded and even burned in Suriname. And on the side of this protected agriculture structure, we had a guttering system installed to capture all the rain, and this rain is distributed through a piping towards the water reservoir that has a capacity of 480 cubic meters. The whole system is powered with a 60 kilowatt solar power system, which all the extra energy that is being produced or sent to the local energy company, which they have an agreement with the farmers that every extra energy that is being sent back to the local energy company is being deducted from his monthly household bill. Further, we had 2 micro irrigation systems installed for a farmer that produce leafy vegetables on an area of 4,000 square meters. There we have micro overhead sprinkler irrigation systems installed. These systems, if you compare to the traditionally irrigation systems used in Suriname, we have the impact sprinklers that have quite large water droplets, which require more energy from the pump, which increases cost of production. This micro overhead sprinklers, compared to the impact sprinkler, require less water pressure, which is benefit for the farmer in regards to cost of production. Sorry. In regards of the drip tube irrigation system, we installed at an area plot of 2,000 square meters for a farmer that deals with fruit vegetables. In this case, it was tomato and sweet pepper. And both systems was completely designed to be used for fertile irrigation system. We had the fertilizers injector installed that allows the farmers to calculate precision doses for each growing stage. It also minimized nutrition loss by runoffs. So all these little tweaks that we have put in place for the farmers is directly, you could have seen the efficiency when it comes to the cost of production. I just want to highlight certain components that we have used during the installation of micro irrigation systems, whether it was for the overhead sprinklers or the drip tube system. The important components in this is the type of filters used. If you don't have good filters, then your irrigation system will not flow. The main problem that most of the farmers have is the maintenance of the filters. When is needed and what to do when you see pressure being lost. So during the training, topics has been highlighted on the area of maintenance, also maintenance of the whole system. In this regard, the filters, when you see like pressure dropping to 6 to 8 C between the inlet and outlet, you definitely have to start cleaning your filters. In regards of the fertilizer injectors, there's a diagram how it functions. It works through a piston system. It doesn't require extra energy. It uses the same water flow from the pump, and it is a very efficient system when it comes to the calculation of doses for each growing stage of your plant. They are other systems that are being used in Suriname, for instance, the Venturi works quite well, but in regards of the precision to distribute the right amount of calculated nutrition for the plant per growing stage, it might differ each day as long as the pressure of the pump fluctuates. In the picture here, you have an installation of an image of the installation that was done for the protected agriculture structure. We had two injectors installed, each for the protected structure. There were two installed. You see the stock tank where the high concentration of fertilizers are being put in based on the ratio of the fertilizer injectors. In regards of the rainwater harvesting reservoir, I want to stress out that depending on the type of soil, you would need to calculate the slope or the angles for the slope. For instance, we have sandy soil and 45-degree slope work well for us. And we installed 3 water harvesting reservoir of 20 by 12 by 2 meters and lined with a HDPE pond liner to protect it from saltwater intrusion, contamination with saltwater intrusion. On the other photo beneath, on the right side, we see how the binding has been done. The binding of the HDPE pond liner is being done on the dimension, trench dimension of 60 by 30 centimeters. And when you dig the trench, you put in the pond liner and you cover it with the soil. There are different types of pond liner that you could purchase. You could ask the supplier to deliver a one-piece HDPE pond liner canvas based on the size of your water reservoir. The important thing to know is that when you install this HDPE pond liner, you do it during the dry season, because when the soil is wet, it might get stuck on the surface of it, and it would be hard to pull, and it could even tear your pond liner. The other type that we had was HDPE sheets. Those mostly are being used on bigger sizes of water reservoir that you could weld on site. Luckily for us, we had the opportunity to also weld the sheets together as a training for the farmers and the suppliers in Suriname. And in the end, it should look something like the picture on the right side now. Here we had a 20 by 12 by 2 meter line pond liner. In regards to the drip irrigation system, we had the drip tip, and we had arrow drippers emitters with a flow rate of 8 liters per hour. For the drip tip, we used a 2 liter flow rate, and I'm not doing any advertising for Toro, but this is that when you purchase, you have the technical specification for the items you're going to install, so you could calculate all the necessary joints for such an irrigation systems. These are some videos in regards to the micro overhead sprinkler installed in the field. You could see that the droplets, if you're familiar with impact sprinklers, that the droplets of the impact sprinklers will be slightly larger. The specifications for this, there's a different type of micro irrigation sprinklers. The diameters might be different. They have different coloring of these types of overhead sprinklers that speaks to certain working diameters. And in the middle, you see a video of a misting system installed, not just only to pull off or control temperatures, humidity, but we also use it for in crop nurseries. And on the right side, the video you see there, a project that we did with Solanum stramifolium, that's locally known in Suriname as the bolomaka. It's a wild variety of eggplant that grows mostly in waterlogged areas and has great capacity when it comes to combating soil-borne diseases. On this wild eggplant variety, we grasp tomato that we, tomatoes tomatoes that are being sold locally. As mentioned before, the importance of filters and clean water guarantees the good functioning of emitters, micro sprinklers, and injectors. Some of the achievements under this project was the training of 121 farmers, 22 agriculture extension officers, 21 students of the Anton de Kom University in open field micro irrigation and crop management under protected agriculture structure. We had one knowledge exchange visit where farmers and technical officers had a chance to visit the Center of Research and Integral Service in Protected Agriculture, CRISIA, that is in Santa Anita, Jalisco, Mexico. And one video has been produced on climate change and climate smart technology, where you could, and it's broadcast to the YouTube link also mentioned there. The farmer's experience in regards of quality and harvesting time, we had on the protected agriculture, the farmers mentioned that they only could have harvest the whole year round, and in open field condition, they saw the difference that they could only harvest till 3 months after planting. In regards to weekly fruit set per plant, under the protected agriculture structure, it was higher, and under open field condition, it was lower. Quality of fruit on the protected agriculture structure, they didn't see any sunburn, and in open field, sunburn were presented. Fertilizers, the plant react faster on the protected agriculture structure. In open field condition, the plants react slower. Washing harvest fruit, it wasn't necessary on the protected agriculture structure. And open field, it was necessary or required. You had more yield or higher yield per plant on the protected agriculture structure compared to open field, it was lower. And the taste of the fruit, in this case, it was the paprika, it was sweeter compared to the open field conditions, which was slightly bitter. The positive agroecological practices and benefits of this project was by using rice chaff as growth substrate and river sand, it substitutes traditional practices of burning of rice chaff, which cause CO2 emission, which is one of the gases that adds to the green gas, the effects of green gas, and the climate change. Growth substrate can be reused for open soil amendment for amelioration of pond replacement, using rain water harvesting system that is good quality for irrigation, reduce water consumption through micro irrigation up to between 85 to 100% efficiency versus average rate of 60% with other methods used, and reduce post-harvesting cleaning, reduce use of pesticide, weedicide to soilless culture and protected cultivation environment, more efficient use of fertilizers through hydroponic system, which reduce leaching of agrochemicals into soil and groundwater sources, reservoirs with protective lining protect stored irrigation water from contamination by saltwater intrusion, reduce crop losses due to reduced incidence of weed, ground cover, reduce incidence of pest and disease through a fully enclosed structures with anti-insect netting reduce impacts of environment factor due to controlled environment, looking at sunburn and flooding, for instance, in an area, nutrition and moisture deficiency disorder, and chemical injury.